Hello, good morning. Not that easy to continue after this inspiring speech. I'll try. And please allow me to start with the 3 questions I'd like to put to you. Are you in any way engaged in the development of automated and electrified vehicles? Then please raise your hand. Okay, I would say 50% roundabout. This morning, did you use an electrified vehicle to come to this place? Please raise your hand. There's 1. Okay. This morning, did you use an automated vehicle to come to this event? Please raise your hand. Not even level 2? Okay, some, few. Thank you. What does this little survey tell us? It tells us we are already a bit on the way in the new world, which Phil depicted in his speech, but there are more initiatives and we are preparing for more. And this is the thing I want to talk about today, and I want to share some ideas how we can prepare for this new world. The future of automotive is automated, connected and electrified, that's for sure. And this opens the door for new user experience. Okay. For new user experience, but this is only one step. And this new user experience and this automation and the connectivity and the electrification is the prerequisite for the big step for the shared mobility with driverless vehicles. I think this is the main challenge and the main change that we see coming, and this is certainly a game changer. It's a game changer because it would reduce the need for vehicles dramatically. If you share mobility, if you have vehicles, then you need much less vehicles than you would need when everybody owns an own vehicles. And I think, and I'm really sure that this transition will come, so the only question is how fast it will come and to which extent it will come. Hard to tell, I guess nobody knows, but it's good to be prepared. It's good to be prepared for the ACE world, so just this new user experience, and of course we could gain the benefits that we just heard in the speech of electrification. So we need to prepare for this. And on top of this, if we do the preparation, then we are already prepared for this shared mobility. And I'd like to share some ideas what we can do here in the EE world to be prepared. Going a bit into details. A lot of things will change, have already changed, and will change. And what I listed here are some aspects of the EE world that are on the way of change and already have changed. I'd like to highlight some of these aspects and present some ideas how the change will look like, at least from my perspective. Let's start with a look at the hardware, at the ECU topology and the ECU hardware. Today, the topology is mainly domain-oriented architecture with some function ECUs and with some domain controllers, and the ECUs themselves, they are based on microcontrollers. What can we expect? If we look into the future, we see 3 types of ECUs. The first level is the sensor and actuator ECUs. They will provide basic functionality. These can be commodity ECUs, not too much variance, and maybe can be shared between different OEMs. Then we have the integration ECUs. We partly have them already today, but the change that we see here, these integration ECUs won't be any more domain-oriented, they will be zone-oriented. So meaning that they're located to reduce the effort for wiring harness. Functionality that is put on this integration ECUs may be a bit different. Then the vehicle brain, this is the new thing, high performance, few high performance controllers providing a lot of computing power to the car. This is an IT-like software that we will have there, more information to come. And this will be the focus of innovation, and it will be the focus of differentiation between the different car manufacturers. They will be linked to the cloud. This is what we already partly see today, and this will be much more intensified in the future. If we now have a closer look into the vehicle brain and its architecture, we see that the vehicle brain, the hardware of the vehicle brain is a SoC. And what does it mean, SoC? SoC means we bring in the computing power of a microprocessor into the automotive world. Microprocessor with many cores typically, and this microprocessor together with a safe hypervisor allows to have many different partitions on this one microprocessor which share the same hardware but are still very well separated. These partitions can have QM applications, as we see on the left-hand side, and if you use QM applications, it's okay to have it's a good choice maybe to have a Linux or an Android operating system. So this is fine for QM. But on these microprocessors, we also will see safety-related applications. And there, we need a different operating system. We need a safe POSIX operating system. And we need the safe variant of adaptive AUTOSAR as the basic software here. And then beyond this, on the right-hand side, we see a microcontroller is still on this SoC typically, and it serves for real-time support, and it can also be used for safe, to add the safety from fail silent to a fail operational system. In this case, we use this microcontroller and we use the classic AUTOSAR within a safe version on this microcontroller. So this is the setup that we see, and it allows and gives high flexibility to combine the good things and the benefits from the different worlds, from the high flexibility, a lot of computing power, to real time and safety on the other hand. So this is how we see the world changing on the hardware side, going to cloud, HPC, high performance computers, zone orientation, and the microprocessor and SoC on the hardware of the ECU itself. Looking at the aspect of software frameworks and software platforms. The software frameworks, software platforms as we have them today, are mainly based on AUTOSAR Classic, and they are mainly managed by the tier ones. So if we look at AUTOSAR Classic and we look at the penetration that's undergone in the last years, we see that, yeah, AUTOSAR Classic is clearly the favorite system as the supporting the user application development as the basic software first choice. A bit earlier in Europe and a bit later in Asia and North America, but no doubt it's the #1 choice as basic software in the meantime. And classic AUTOSAR will prevail. It will be used in future for the sensor and actuator ECUs. That's the home turf for these for the classic systems, and it will be used there. But we also see this to be used in the integration ECUs, and in the case of fail operational, as I mentioned, it may also be used in the vehicle brain ECUs. AUTOSAR Classic is its character. It's a static world, the classic world. It's a monolithic approach, and all this is to improve the efficiency, and maximal efficiency is the main goal of AUTOSAR Classic, and it's really good in this. Then we look at the adaptive AUTOSAR. Adaptive AUTOSAR is different. Adaptive AUTOSAR, its main goal is maximal flexibility. Of course, it costs some performance, but its flexibility has a lot of benefits. It's dynamic, it's modular, you can change things very easily, and this is a big benefit during the development, but also then during operation later in the field. Adaptive AUTOSAR, its main application field is of course the vehicle brain, but depending on the functionality, on the integration ECUs, it can also be useful to have an adaptive instance on the integration ECUs. One thing to mention here, that it's one advantage of combining AUTOSAR Classic and adaptive is you have a seamless interoperability. The communication between these two systems is easily done, and the system design of the whole system consisting of classic and adaptive can be with one approach under the headline of the AUTOSAR methodology. Okay, now the AUTOSAR adaptive Specification, in the meantime, it's a mature specification, so the question, what about the market penetration? Is it visible in the market? What will be the future of adaptive? And what we see here, that the two well-known first projects of serious production projects of adaptive, the Volkswagen, the full electric vehicle of Volkswagen, just been presented some days ago with its SOP in 2019. And then a bit later, we will see, 2 years from now, we will see the next implementation or the next step of adaptive in an ASIL-D version in the full electric BMW iNext, which is focused on, it's an electrified vehicle and it's an automated vehicle. There are some other serious production projects which are not public, but there are some, not that many. But really interesting is that what is on the way now, what can we expect in the future? And we have counted more than 150 projects using adaptive AUTOSAR for evaluation and for prototyping purposes. So this is a big wave that is coming, so we will certainly see more from adaptive in the future. If you look at the architectures in the ECU, adaptive is the basic software for these high-performance computers, but some OEMs think to add more functionality as to provide more basic functions beyond AUTOSAR adaptive. And we would call this a software runtime framework. They partly call this a vehicle OS. Most famous example of this is the Volkswagen OS, where they have a basis of AUTOSAR adaptive and then some things beyond this, and I want to touch this a bit on this slide. And it's basically everything that is between the user applications and the hardware. This is what we would call the software runtime framework, or maybe a vehicle OS. It consists of the AUTOSAR basic software. Then on top of it, or beyond, below this, there's the hypervisor. There are some libraries attended to it, some security extensions, which are not part of AUTOSAR adaptive, some features to support the development, like resource monitoring. And then we have some OEM-specific system services like diagnostics and like functions for the software update. We could even put some basic applications, data servers and personalization features in this software runtime framework, and to have a comprehensive support for to enable and to make easier the life for the user application developers, because they can rely on a very powerful basis. The elements of this runtime framework can be provided by OEMs, by tier 1s and by tier 2s. That's open. This is a very good approach. We think this will be what we will see more in the future. One little remark I'd like to make here, addressing the OEMs. We see that many OEMs are developing this individually and independently from each other. And we think this is not the best idea. Why not save time, money, effort, gain shorter time to market by doing it together and trying to reduce the OEM-specific functions to the real minimum that's really needed to avoid double development. Okay, now we have this runtime software framework. We have the user applications, and this is then the whole ECU software that's made of it. And so the question is now, are we done? Is it all that we need for this future high-performance ECUs? It's certainly not. We need a tool or a set of tools, a tool environment to develop this ECU software consisting of runtime framework and user applications, design, configuration, integration, of course, and testing and calibration at the end. And this tool has to have a high focus on as much automation as possible. We all want to use CI environments and only asking the user to interact whenever it's really needed. So this is a step that allows the development of the software runtime framework, and the quality of this kind of tool makes a difference because it saves time, it saves effort, and it increases quality if it's a good one. Now, is that all that we need? No, it's not. What we need beyond this, and that's often forgotten, We need a software platform architecture. We need to be able to provide, as called here, one software for everything. We need to be able to provide software for different projects in a certain variation, because we certainly don't want to develop the software from the scratch for each project following. We want to build up a platform, defining platform components and variants. This typical idea of having a 200% product, then a 150% program, shrinking down a bit, maybe to mid, high, and low, and then the project itself is then this 100% version. So this needs to be defined, and this is quite a big invest to set this up, and it's very often underestimated how much benefit it brings, but on the other hand, partly underestimated how much effort it is to set this platform architecture up, and on top you need a strategy and some techniques to maintain this architecture over time and to derive the project-specific solutions. You want to do a reuse, update, and of course you need to merge, otherwise you end up with many, many variants and not gaining the benefit of this platform architecture. So big thing, and what we see in discussions with our customers, there is not much experience and know how to do this. So there's a lot, quite some time needed to really get to this point by having a high-performance platform architecture. So then we have this. Is that all that we need? No, it's not. We need a tool to manage this platform architecture. This cannot be managed manually. We need a tool that does not care only for the source code management of this platform architecture, but we need to manage all kinds of artifacts that are used within this development workflow, and they need to be managed, and there need to be the full traceability between these artifacts. And this platform development framework needs to support the management of the platform and the parallel working in distributed teams that may be distributed around the world, but also may be distributed among different companies. Very important step, increasing efficiency and speed of the development. Now, is that all that we need? Still, it's not. On top of this, we need processes, and we need a good organization. We need processes to support the agile development. We need processes to support safe development, secure development, and, very important, we need a good organization. We need an organization that's really intended to support this approach in the best way, and an organization that is oriented along ECU borders. That is probably not the good way to organize it. And Phil in the speech talked about organization, and I think that is one thing that he mentioned, and I agree. If we try to work on the new stuff with the old organizations, that wouldn't work. But I'm optimistic that the companies that work in the automotive field for many, many years, they are able to change the organization. So to sum this up, we see software frameworks from Classic, then we see on top of Classic, we see Adaptive, we see these runtime frameworks, development frameworks around it, and more important, we see that the platforms are not only managed by the tier ones in the future, but they are also managed by the OEMs. Okay, next topic, or last topic I want to go a bit more into details is the work split. In the past, the work split was more or less ECU oriented. So for each ECU, there was one tier one developing the ECU and then providing it to the OEM. Now this will change as well. This picture shows the development workflow in an adaptive environment. And don't be afraid, I don't want to go to all the details. It just shall show it's quite a complex workflow, and different parties are contributing to the whole development. There are the OEMs, there are different tier ones that are contributing, and different tier twos are contributing. And all of them are contributing according to their special know-how, to their knowledge, to their expertise, and the contribution is not done, let's do do a development separate from each other for 3 months and then let's get together and put it all together in a plug fest. No, it's a continuous collaboration between the parties. And this is another change that we see here, that this stage-wise approach, getting together every 3 months or maybe making a release every 6 months is not sufficient anymore. We need a continuous integration. And believe me, we have some experience, we have made some experience in this transition to this new collaboration principle, and it's really a big change because it's so much change in this interaction between our customers, but also internally it requires some change in our concepts and how to work together. And of course, you need an approach that is more agile than it used to be in the past. So this changes a lot. And as I said, the different parties contribute according to the expertise. And I think in future we will see more and more of not ECU-oriented work split, but discipline-oriented work split, I called it. So some care for the application functions, some care for the basic software, and some, typically the tier 1s, care for the hardware. Now these are the 3 topics I wanted to highlight a bit, but there are more. You're listed, you see them here. And I can spend some words on the other topics. Software architecture, we mentioned already a bit that we don't see the monolithic approach in one ECU, but we see more a modular approach in the ECU. So an ECU is not made of one software, but it's made of software clusters, as they're called, and each cluster consisting of different services. And we want to have the flexibility to move services from one ECU to the other ECU. And based on this idea of service orientation, it doesn't really matter where the service is in the phase of service discovery. The whole system finds where the service is offered and where the services are used, so it gets together very easily. And this is important. The design is not done at the development stage. The design and the setup is then finalized during the operation. It dynamically changes the provision and usage of services. Software configuration, already mentioned a bit. In the past, we have static configuration, and now we are going more to manifests, which is typically in the IT world. Each software component brings its own manifest and telling the system where it's applied, how it should be installed, and how it should be started. We see quite a movement in software languages. C was the system and was the language for many, many years. Now it's adaptive is based on C++, and many applications are based on C++, but we see other languages as well, like Go and others. They are very modern. They have the little constraint that they are not that efficient, and we will see how this turns out, because looking at the efficiency and performance is still an issue. One thing that we have learned in the ongoing projects with these high-performance computers, the first assumption saying, well, when we have these high-performance computers, computing power is infinite. We won't have an issue anymore with computing power. That is different in the real life. So we still see that computing power is still an issue, and therefore we will have a look which language is the right one to be used. Communication, yeah. It was signal-based, it was based on CAN-LIN and FlexRay, and now it's service-based more and more. And of course, Ethernet is the story and is the big change that we see in communication, supporting in the meantime also real-time synchronized communication, so it can, in these terms, it can completely replace FlexRay. Development, already mentioned a bit, development pattern was static. Now, in the future, we see more and more agile approaches, CI, continuous integration, continuous testing approaches, and an intensive collaboration between different parties. Software lifecycle also, software is not frozen anymore at SOP. We see and expect more of it to come, update and upgrade over the air, I think, well known to everybody. So what does it mean? It's from my perspective at least, it's a big change. A lot of things have changed and have to be changed. And it's not only a change, it just comes on top, because the old systems still have to be developed and have to be maintained. And therefore, it's quite a challenge to get along with those things that we expect are needed and are good enablers for the future of the automated, connected, electrified, and maybe shared vehicles. So maybe one final sentence: to cope with the future challenges, we need to adapt in many aspects. And I think it's hard if everybody does it on its own. I think it's good to join forces here and to find the best way to complement each other. And the last point I'd like to make, and we need to capitalize our old strengths. So we have a lot of experience gathered over the last 30 years or maybe even more, and we will need these strengths in future as well. And we should not forget them, we should really capitalize them, because they are still part of the system that we will develop in the future. Thank you for your attention, and I'd be glad to answer some of your questions. Thank you.